Sorry about that. Okay, so I know the perimeter is that, but I know two sides, right? Let's call this on the unknown side y. So don't I know that 536 equals 163 plus 210 plus y? Well, 163 plus 210 is 373. If I subtract 530 or 373 from 536, I get 163 equals y. Well, look, these are the same. So if these are the same, doesn't that mean then that this and this are the same? Even though, don't go by the looks of this triangle, because obviously it doesn't look like an isosceles triangle. But if these two sides are the same, this is an isosceles triangle, and that means that these two are the same also. So, let's see, LM is, let's fill this in. But now I want to know what angle M is. So I know that x plus x, well, let's do it this way. X plus x plus x is 3x plus 30 has to equal 180. Subtract 30 from both sides. Divide by 3, so x has to equal 50 degrees. Oh, God, that was covered up the whole time. I'm sorry. I would pause right here and make sure that when you do the work that you get the same answers I did. Okay, let's look at number 8. This is a isosceles triangle because these sides are the same. That means that this is the same as this, and that all 3 of them add up to 180. Well, here's a dilemma. Because I have 2 variables, that means I have to have 2 equations. I need, let's separate this. I need 2 equations to solve for 2 variables. So let's think of the 2 equations that we have. Well, don't I know that this is equal to this? So my first equation is 2x plus y equals 79 minus x. And don't I know that I have another equation that all 3 of these equal 180? So 4y plus 79 minus x plus 2x plus y has to equal 180. All right? Let's clean this up a little bit. So 4y plus y is 5y. 2x minus 1x is 1x. And plus 79. And if you will remember from algebra when we did systems of equations, I'm going to continue this problem right here because I don't think I continued it anywhere else. Okay, so this is what I have for my first equation. This is what I have for my second equation. So now I have 2 equations with 2 unknowns, and I can use a couple of different ways to solve them. I can solve them with elimination. I can solve them using substitution. I could graph, solve for y and graph both of them and see where they intersect. I'm going to rewrite both equations so that my x and y are on the left-hand side and my constants on the right to see if I can use elimination easily. So I'm going to add x to both sides, rewrite this as 3x plus y equals 79. I'm going to rearrange these because I want x listed first. And then I'm going to subtract 79, so it's on the other side. Okay, well, I can't easily do elimination here, but I could solve let's use substitution. I'm going to solve this equation. I'm going to get rid of this. I'm going to solve the second equation for x. So x would equal 101 minus 5y. All right? So now where this x is, I'm going to replace it with this whole thing. I'm going to substitute it. So I know that 3 times 101 minus 5y plus y equals 79. Use the distributive property, 303 minus 15y plus y equals 79. Collect my like terms. Minus 14y equals 79. If I subtract 303 from 79, well, let me get my calculator. 79 minus 303 is negative 224. Over here I have negative 14y. Divide both sides by negative 14. And y equals 16. Okay, if y equals 16, I'm going to plug it back into that right there and solve for x. So that means x equals 101 minus 5 times 16. This would be 101 minus 80. X equals 21.